Now let's see the implementation of the directory. Directory can be implemented in two ways. Now either you can maintain it as every directory as if it is a list of files, and that list could be a simple linked list, or you can maintain a hash table. So I'll tell you what is the advantage and disadvantage. Anyway, the main thing that you should be considering while choosing a data structure is what is the performance and what is its reliability, right? So let's see this. The selection of the directory allocation and directory management algorithms significantly affects the performance and the reliability of the file system. So what type of algorithm you are going to use, that depends on what type of data structure you are going to use. Depending on the data structure, your algorithm is going to give you performance, right? Now one simple way of implementing the directories is you can maintain all the files in a directory as a list. If you are going to maintain all the files as a list, a simple implementation is shown here, right? Let us say we are maintaining all the files in a linked list, single linked list. Now in this case we are going to have a file name and what are all the data blocks which are assigned to it. As I told you, every file is going to be allocated some data blocks, isn't it, within the volume. Now if it is having, let's say, 4 blocks, this file is having 4 blocks. Now all those 4 logical blocks have to be assigned 4 physical blocks, and the information about the 4 physical blocks is present here, and this is the pointer to the next file. Now like this, if you maintain all the files within a directory as a list, then what is the problem with this one is, if you have to create a new file, you might have to search the entire list to know whether the current the new file name already exists or not. In case if it doesn't exist, we can create it at the end or at the beginning, that's not an issue, but anyway you have to search it. Now second thing is, if you have to open a file, then again you might have to search the entire list, right? Or if you have to delete a file, then again you might have to do a search. The search operation is going to take a lot of time if you are going to implement it in purely as a linked list, right? So what is the other alternative is, have this linked list, along with that you can have a hash table, right? Now by maintaining the hash table, let us say you are maintaining a hash table like this. Now it can have key and value pairs, key and value. Now based on the file name you can form the key, right? So based on the file name, if you apply hash function on the file name, then you are going to get the key and you are going to save the key there, and the value for that may be the file to which you have a node there in the linked list. Got it? Now by using this hash table, the advantage is search will be faster. If you are trying to create a file, then you can directly search in the hash table in order of one time whether that file is existing or not. If you want to open a file, you can directly go and open it. If you want to delete a file, you can delete it, right? So that is how hashing will be better compared to this, but still hashing is going to have some disadvantages, like it is going to be in fixed size. So every time you have to increase the size, the number of files are going to be increased. And also the other problem is there might be some collisions. So whenever you have to have collisions, then you might have to use open hashing or chaining or whatever techniques we have discussed in algorithms. Therefore both of them are having advantages and disadvantages, and whatever you want to use, that is up to you, up to the implementers, right? And even the directories are also implemented in the form of lists only, right? And sometimes you can even use B trees and B plus trees. If your number of files and directories are very large, then you can go with B trees and B plus trees, which we have discussed in DBMS. Okay, so anyway, these are the two popular methods which are currently under use. Okay.